Hello students, this is Miss Ruiz. Welcome to today's video. Today we're going to be doing something a little bit different. We're going to make a quick reference guide that you can have in your notebooks to help you keep all of the rules and processes that we've learned when it comes to adding, subtracting, multiplying, and dividing positive and negative numbers. So in this example, we're going to set up our page like this. I'm going to zoom out so you can see a screen in the full screen, how you're going to set up your paper. So you're going to have your title at the top with the date. And the first section, we're going to talk about subtraction. So make sure you kind of leave enough space here to set up for a subtraction. In the center, we're going to go over addition and the addition signs. And remember, for addition, we can have different signs or the same signs. And then at the bottom, we're going to go over multiplication and division. Okay, so pause and set up your page. You don't have to write everything yet. If you want to write it as I go and pause, that might be beneficial to help your understanding. Okay, so for many of you, this is just a review. And for those of you who are still a little bit confused, especially once we brought subtraction into the classroom, hopefully this will help to clear everything up. Okay, so beginning at the top here with subtraction. Okay, so the first thing we have here is the rule for subtraction. And we know that when we are going to subtract, we are actually going to be adding the opposite. Okay, so by now we should understand what that means. We're going to change subtraction to addition, and the following number will become its opposite, or we're going to use the additive inverse. Okay, at that point, it will turn into an addition problem, so we'll have to follow down here the addition rules. So I have two examples, one that will become each type of addition rule, so you can see how subtraction and addition are affected by each other. Okay, so pause it and copy down all of what you see here for the subtraction area. And you might want to copy this note as well. Remember that the first number never changes. So when we start doing these problems, you'll see as I usually do, I'll color code. The numbers that don't change will stay the same number. Everything that changes will stay the same color, excuse me. Everything that does change will change color. So pause and copy down all your notes. Leave space where you see I have space for work. Okay, so now that you've copied that down, let's start with this first example over here where we have negative 14 minus negative 8. So if you remember in class, I've emphasized this a lot with you guys. Before you start any problem, before you start considering positive or negative numbers, what operation you're going to do to solve it, I want you to focus on what operation is being presented to you in the problem. What is the initial problem showing you? And here we know this is subtraction because I see a minus sign. Okay, so regardless of what you end up doing to solve it, you want to check what the operation is initially. This minus sign in between the two digits, negative 14 and negative 8, tells me this is subtraction. So I have to apply the rule of adding the opposite. Okay, so here we go. I'm going to make my changes. So when it's subtraction, the first number never changes. So that's going to remain negative 14. I'm then going to change my subtraction sign to an addition sign. And the following number is what changes. So in this case, I have initially a negative 8. Its opposite is going to be a positive 8. Now you look at the new problem that has been created. It is an addition problem. So this is the problem that we're working with. The initial problem they gave us no longer exists. We've made it an addition problem. Because there is a plus sign between the negative 14 and the 8, I have to use the addition algorithm or the addition rules. And for that, you have to check to see if your signs for both numbers are the same or are different. In this case, they're different. So that's why I have written down here that we're going to apply the rule for adding adding numbers when the signs are different. So when we go into addition, we're going to practice those. So moving over here to the second subtraction problem. I have negative 26 minus 10. So once again, there's a minus in between the negative 26 and the 10. I know I need to add the opposite. So the first number remains the same. I'm going to change subtraction to addition, and instead of a 10 here, I'm going to change it to a negative 10. Instead of this positive 10, it's going to be a negative 10. And now I look at the new problem that I've created. There is a plus in between those two, so I'm going to rely on my addition rules. My signs are the same, so I'm going to follow the rules for when you're adding and the signs are the same. So hopefully you're realizing here that every subtraction problem will turn into an addition problem. Okay. So here we are with our addition rules. So let's go back to the initial problem, the first one we did. We changed and we got a negative 14 plus 8, a negative 14 and a positive 8. That is an addition where your signs are different. So the rule here we've gone over is that when the signs are different, we're going to subtract them and use the sign of the larger absolute value. We've also done this in class with counters, where you would have 14 negative counters or 14 red counters, and we pair that up with 8 yellow counters. And every time a zero pair, a yellow and a red counter touch, they cancel each other out. Okay, so we've gone over that a lot in class. So let's see here. We're using this algorithm, I'm going to subtract their absolute values, which means I'm not going to consider any positive or negatives. I'm just going to look at the two numbers like we did in elementary school. 14 minus 8 would be my subtraction. And that's going to give me 6. So my answer is going to be a 6. But because they're different signs, I need to decide if it's going to be positive like the 8 or negative like the 14. Well, if you look here, it says that we use the value or the sign of the larger absolute value. 14 is negative 14 has a larger absolute value of 14 than 8. And since the 14 is negative, my answer will also be negative. Remember, write down any questions you may have, or you can send them to me on Remind, and we'll discuss them when we get together in class. Okay, moving over to the problem that we created in subtraction, and it became an addition where the signs are the same. When the signs are the same, we simply add the two numbers and we keep the sign that they have in common. So if the two numbers are both positive, the answer will be positive. If both of the numbers are negative, so the answer will be negative. So I've got a negative 26 plus a negative 10. Both are negative. All I have to do is simply add 26 plus 10 to get 36. And since both of them are negative, my answer will also be negative. Okay. So I hope that seeing it this way will give us a clear view of how subtraction and addition are interrelated. Every subtraction problem is going to become one of our two addition situations. Then down here, everybody's favorite, the multiplication and division. So we've gone over this before. I know you have this in your notebook elsewhere. I'd like for you to have it all on one page, especially since we're going to be doing this now with fractions and decimals. You want a quick reference. So we've already talked about this box here. We know that this box applies for multiplication and division, only multiplication and division, not addition and subtraction. How many of you guys have tried to apply this to addition and subtraction? I know we've gone over that in class a few times. All right, so let's start on this side here with the multiplication. We've talked about what multiplication will look like. Usually we'll see it with parentheses like this one in the middle. Sometimes you'll still see the dot. So we're multiplying when we have two positive numbers, like positive 3 times positive 3, that's this first situation here. A positive multiplied by a positive is going to give me a positive 9. In the second example, we have negative 4 times a negative 6. A negative multiplied by a negative will also give us a positive answer. 4 times 6 will give us 24. And in the last example, we have one like the last situation where one of the numbers is positive and the other one is negative. Remember that in multiplication and addition, we have the commutative property where the order does not matter. So it doesn't matter if the negative is the first number or the second number, as long as they are two different signs, you're going to multiply them and the answer will always be negative. So here we're going to have a negative 15. The same exact rules apply for division. Remember that now we're more often than not going to see division displayed as a fraction. Fractions are division. So we're going to apply the same exact rules that we have in the box. We have a positive 9 divided by a negative 3. So both of them are positive. My answer will be a positive 3. In the second example, I have negative 25 divided by a negative 5. Both of the numbers being divided are negative. The answer will be positive 5. And in the last example, we have a negative 75 divided by a positive 3. So one of them is negative, the other one is positive. My answer will be a negative 25. Okay, so as long as you have this in your notebook, I will be checking it in class. It will be a good reference for you to have while we're working on problems, especially the word problems we have coming up with fractions, with decimals, and also with integers. You want to have a place to look if you start to get confused. I'll be checking this in the next class, and I look forward to seeing you then. Bye, guys.